What's up, math scholars and math haters? This is Mr. W. Today we're going to tackle question 41 in the 6th grade math questions that North Carolina released this past school year. We see that a store sells cans of tomatoes priced as shown, and we're trying to figure out which size can of tomatoes has the lowest cost per ounce. Alright, so in order to do a question like this question deals with unit rates, and I'll go over exactly what that is. So essentially, we're looking for which size can of tomatoes has the lowest cost per ounce. The key words here are cost per ounce. Now, if you've seen any of my other questions where I look at the word per, I usually take that to mean multiplying. But now we're in kind of different territory here. We're not really thinking of this in terms of an equation. Now we're thinking of this in terms of unit rates. And so I'm actually going to translate this into a fraction. Cost divided by ounces is the same thing as cost per ounce. This is the easiest way to find a unit rate for each of these size cans of tomatoes. And so now, and one more quick thing, in this case, the word per kind of translates to that fraction bar. So in other problems, per could translate to multiplying, but now that we're in unit rate territory, I find it easiest to think of cost per ounce as cost divided by ounces, where per becomes that dividing sign or the fraction bar. So let's go ahead and test out each of our answer choices. Choice A, or actually we need to go ahead and just figure out our unit rates so we can compare them. So for the 10-ounce can, if we're finding the cost per ounce, that's 0.89 or 89 cents divided by 10. So the cost in cents divided by the size in ounces, that's 0.089. So that's 89 thousandths of a dollar for every ounce of tomatoes. Next, I'll test the 15-ounce can. Cost per ounce. Cost is $1.29. Size of the can is 15 ounces. I figured that out, and this is 86 thousandths of a dollar. I come up again and try out my 18-ounce can. Cost is $2.26. 18 ounces gives me 0.12, and then it looks like this 5 is repeating. Either way, I can just tell from the tenths place, because I have a 1 in my tenths place, whereas I had a 0 in my tenths place in both my other answers, that this is not going to work. So now I move to choice D, where I test a $3.39 can of 32 ounces, and again, that gives me a 1 in my tenths place, which I know is going to be, even if I don't know by how much, I know it's going to be bigger than each of these, where I had a 0 in my tenths place. Yeah, it's a little easier to see now. So I have two that I know can't be right, 89 thousandths and 86 thousandths. Since I'm looking for the lowest cost per ounce, that's going to be choice B. The 15-ounce can that cost $1.29 and ended up being 86 thousandths of a dollar per ounce of tomatoes.